In this video, I'm going to show you how to build this bike frame in a fully parametric way using FreeCAD. We'll go over several techniques that'll seriously boost your modeling skills. And since they are not exclusive to FreeCAD, you will be able to use them in pretty much any CAD program. This tutorial is for beginners or for anyone who wants to quickly improve their 3D modeling skills. And you'll see, it's really something anyone can do. To help you follow along with this tutorial, you can download the sketches and the 3D model of the frame for free on my Ko-fi page. It's completely free, but if you'd like to support my work, you can leave a donation. It helps me a lot. Thank you in advance. When you first open FreeCAD, you'll see this welcome message. It asks you to set your language, a unit system, a navigation style, and a theme. I'm going to set the navigation style to the Revit one. I'll also pick the light theme so the icons are easier for you to see. For this project, since we'll be using several workbenches, let's click on the empty file icon to start with a blank page. Our goal here is to create a bike frame that's fully parametric. To do that, we'll start with a base sketch that all our parts will be linked to. In the CAD world, this is usually called a master sketch. Since this sketch will stand on its own, we'll use the Sketcher workbench to create it. To do that, open the drop-down menu of the workbenches and select Sketcher. Next, click on the sketch icon on the left to start creating. In the pop-up window that appears, you'll be asked to choose a plane on which your sketch will be created. Since this is a side view, we'll select the XZ plane, then click OK to confirm the orientation. To create this sketch, you need to think of it a bit like the skeleton of our frame, where the lines will act as the bones. For this, we'll use the Polyline tool, which lets us draw multiple connected lines at once. We'll start our sketch by placing the first point at the origin of the axis. This origin point will be the position of our bottom bracket, which is the central part of the frame. From there, we'll move upwards and slightly to the left to mark the position of the seat tube. On the right of the line, you'll see a preview of the length. Try to aim for a value close to 200 mm. Left-click to create the line, then continue your sketch to the right to draw the top tube. Try to get a value close to 550 mm and create a point. Next, move downwards a short distance to create the head tube line, then left-click. After that, connect back to the origin to draw the line of the down tube. Now we're going to draw the rear triangle of the frame. We'll continue the sketch starting from the top of the seat tube and ending slightly below the horizontal red axis, then reconnect the line back to the origin. To stop using the tool, right-click or press Escape. On a bike frame, the head tube is usually longer than this, so we'll draw a small line below the bottom point of the head tube. Next, we'll draw the line representing the fork and stop it just below the red axis. In the same way, add a small line above the head tube. The total length of the head tube will be made up of these three small lines. Next, go to the top point of the seat tube and draw a small line above it as well. Now that we've finished the sketch, we can check if the points are properly connected by trying to move them. But as you can see, the geometry isn't constrained at all yet, so we'll use several tools to fix that. To start, we'll make the lines that belong to the same tube parallel. To do this, select the small line and the long line of the seat tube and use the parallel constraint from the top menu. You need to do the same for the head tube and the fork. So select the three small lines and the long line, then apply the parallel constraint. I just realized I forgot to draw the line connecting the two wheel positions. We'll need it later to constrain the sketch. So use the line tool and draw a line between the two endpoints. Next, we need to turn this line into a construction line. To do that, select it, then click the construction icon in the top toolbar. Then with the dimension tool, we'll set the fork height. Since it's a BMX with 20-inch wheels, we usually go with a height of 317 mm. Still using the dimension tool, we'll set the head tube length to 120 mm. To do that, measure from the top point down to the fork point. Make sure the dimension is parallel to the tube, not vertical. As you can see here, the points aren't perfectly aligned anymore. No worries. Just click and hold the top point of the head tube and move it upward. With the dimension tool, we'll now set the length of the small lines. Give the bottom line a length of 45 mm and the top one 30 mm. Each time, make sure the dimension is parallel to the line, not vertical. Now we'll define the front angle. Using the dimension tool again, set an angle between the fork line and the horizontal line and give a value of 76 degrees. You can see now that the horizontal line is above the red axis. No problem. We'll move it below by clicking on it, holding the click and dragging it down. Now we'll set the rear angle of the bike frame. Use the dimension tool to create an angle between the seat tube and the horizontal line and set it to 71 degrees. Still using the dimension tool, we'll set the bottom bracket height by creating a vertical dimension between the origin and the horizontal line. Set it to 25 mm. We can now set the length of the top tube, which determines the frame size. Using the dimension tool, set the long top tube to 533 mm. Next, we'll set the length of the rear stays, the chainstays. This is usually 330 mm. Make sure the measurement is parallel to the line, not just horizontal. Finally, we just need to dimension the seat tube. Set the middle line to 200 mm and the top line to 35 mm. At this stage, you should have a sketch with all the lines green, which means it's fully constrained, and that's essential. If you're having trouble completing the sketch, don't forget that you can find both the sketch and the 3D model in the description. Feel free to refer to them for help. We can now exit the sketch by clicking the Close button. You can see our sketch in the tree view on the left. To keep our file organized, select it and press F2 to rename it MasterGeo. Now that we've finished our master sketch, we can start creating the different tubes. Let's begin with the simplest one, the bottom bracket. It's just a hollow tube placed at the origin. To create it, we need to switch to the Part Design workbench. Open the workbench drop-down menu and select it from the list. Since this will be a solid 3D body, we need to start by creating a body. Click on New Body on the left. To create a 3D shape, you usually start with a sketch in any CAD software, so click on New Sketch. As before, we need to select a plane for our sketch. Even though the menu looks a bit different this time, just select the XZ plane directly in the viewport. Since this is a round tube, we'll use the circle tool. Create a circle at the origin, making sure you see the constraint icon as a cross and set its diameter to 45 mm. It's very important that the circle is properly placed at the origin. If it's correctly positioned, the sketch will turn green. Once that's done, you can exit the sketch by clicking Close. To create the solid, we need to do an extrusion. In FreeCAD, this is called a pad operation. To create it, click the pad icon in the toolbar. We want the tube to be centered on the origin with equal space on both sides. To do this, set the mode to symmetric. This will extrude the tube equally in both directions. For the length, a bike bottom bracket is usually 68 mm long, so enter that value. You can then click OK or press Enter to confirm the creation. You can see in the viewport that our tube has been created symmetrically. Now we're going to hollow it out. We could have drawn the tube's thickness in the previous sketch, but we'll need the solid tube for other operations later. So to hollow it, we'll use the thickness operation. To do this, select the two side faces of the tube while holding Ctrl, then click on the thickness tool in the menu bar. In the thickness parameter, enter 2 mm to get an inner diameter of 41 mm. Then click OK or press Enter to confirm. You can then rotate the part to check that everything went smoothly. Select the inner edge of the tube and verify in the bottom right that the diameter is indeed 41 mm. We can then go back to the tree view by clicking on Model. Press F2 to rename the body to bottom bracket mid, with mid referring to the standard 41 mm. Below you can clearly see our two operations, the solid pad and the thickness. Now we're going to design the head tube. It's a slightly more complex tube to model, but we'll keep it simple. The diameter is larger at the ends to fit bearings, allowing the fork to rotate. Just like with the bottom bracket, we'll create a new body. To do this, click the new body icon in the toolbar. By pressing F2, we will rename the body into head tube. Now we'll create the sketch that will help us make this part. To do this, click the Create Sketch icon in the menu. As with the bottom bracket, we'll use the XZ plane, so click on it. To place the head tube in the exact position, we need to use the master sketch as a reference. To do this, we need to project it into our sketch using the external geometry tool. If you try to select the lines from the master sketch and nothing happens, that's normal. Even though you can see the master sketch, it isn't part of this body. We need to use another tool to import it into the body. To do this, exit the sketch by clicking Close. Then in the tree view, click on Master Geo and then click the Subshape Binder icon. This will import the master sketch into the head tube body. In the tree view, you should see a new binder entry. Now hide the master sketch and you'll see the binder in yellow in the viewport. It's basically a copy of the master sketch that we can use inside the head tube. So you can go back to editing sketch 2 by double-clicking on it. Now, using the external geometry tool, we can project the three lines of the head tube by simply clicking on them. To create this tube, we'll use a revolve operation, with the purple line as the rotation axis. We only need to draw the profile of the head tube on one side and the revolve will create the solid. To create the profile, we'll use the polyline tool and roughly draw the shape of the tube, starting from the top point of the pink line and ending at the bottom point. It's important to have the same number of segments as you see on the screen. When you close the contour, make sure the constraint icon shows a cross to ensure the points are properly coincident. Then press Escape or right-click to stop using the tool. Now we'll add constraints to shape our part correctly. Start by selecting the two top lines and apply a perpendicular constraint. Repeat the same process for the two bottom lines. We also need to make the bottom line perpendicular to the small right line. Select them and apply the constraint. Do the same for the corresponding lines at the top of the tube. Now the long middle line needs to be parallel to the purple line. Select both lines and apply a parallel constraint. Next, we'll add dimensions to our sketch. Grab the dimension tool and start by setting the top line to 22.9. For the small perpendicular line, set the value to 6.5 mm. We'll give the same value to the small line at the bottom. We could use an equality constraint, but I find it easier this way if we ever need to change the bottom value later. In this case, both lines are equal, but most of the time they're not. Same logic for the bottom line. We'll give it the same value, 22.9, as the top one. But if we ever want a tapered head tube, this value would need to be larger. That's why I like to keep it easy to adjust later. Next, we'll set an angle for the slanted line. We want it to be 45 degrees. So we'll create an angle between the two lines of 180 minus 45, which equals 135 degrees. We'll give the same angle to the slanted line at the bottom. With the dimension tool, select the two lines, enter the formula 180 minus 45, and you'll get an angle of 135 degrees. On the left, we can see there's only 1 degree of freedom left. That's the value for the middle line. Now, I'm going to do something that might look a bit strange, but it's to avoid reconstruction errors. For a long time, FreeCAD has struggled with rebuild issues, and there are still a few today. When you set a dimension relative to an axis, FreeCAD doesn't always know whether the value should be positive or negative. So sometimes, when the model rebuilds, a line that was on the right of an axis can suddenly flip to the left. And that's exactly what happened to me with this tube when I was preparing the tutorial, as you can see here. So to avoid that, I used an angle of 135 degrees instead of 45, and I added a few construction lines. It seems that the combination of those two things fixed the issue. Another solution would be to use variables, but that's a slightly longer process. To add the construction lines, we'll use the line tool and draw 4 lines between the purple line and the profile. Each line should be coincident with the 4 inner points of the piece, just like I'm drawing here. Next, select all the lines, making sure to include the top one and apply a parallel constraint. This will align them all properly with each other. Then select the 4 newly aligned lines and use the construction tool to turn them into construction lines. Finally, using the dimension tool, set the second blue line to 20 mm. The sketch should turn green, showing it's fully constrained. Once again, if this is moving a bit too fast, you can download the sketch and the 3D model. The link is in the description. Now we can exit the sketch by clicking Close. As mentioned earlier, we'll perform a revolve. We've finished the profile, so all that's left is the operation. With Sketch 2 selected, click on the Revolution tool in the Operations menu. By default, FreeCAD uses the vertical Z-axis as the revolution axis. Of course, in our case, the result isn't correct. Go to the axis parameter and change it to Select Reference. Then in the viewport, select the leftmost line of the profile. Once selected, you should see the operation working correctly. You can then click OK to confirm the operation. Now we'll hollow it out, using a thickness operation just like we did for the bottom bracket. Select the top and bottom faces while holding Ctrl, then click the thickness tool. In the left menu, set the thickness to 2 mm, then click OK or press Enter to confirm. In the viewport, you can see that the operation completed successfully. In the tree view on the left, we'll hide the binder since we no longer need it and it might get in the way. Now let's test if the head tube moves dynamically based on the top tube value in the master sketch. To do this, double-click the sketch to edit it. Change the value from 533 to 580, for example, then close the sketch. In the tree view on the left, you will see that the thickness operation didn't rebuild correctly. To fix this, right-click on it and choose Edit. In the left menu, you'll notice that no face is selected. Sometimes FreeCAD can't find the original face when the file adapts dynamically. There's even a transparent entry. To fix this, right-click on it and choose Remove. Then in the viewport, hold Ctrl and reselect the 2 faces, and click OK to confirm the operation. In the tree view on the left, make the thickness operation visible again. The shell should reappear. Go back to the master sketch, change the value from 580 back to 533 and then exit the sketch. And tada! After the divine intervention of the FreeCAD gods, the problem should be fixed. Just to be sure, you can try other values to see if the model rebuilds without errors. For me, the error didn't happen again. Now we can move on to the other tubes, starting with the down tube. To keep things simple, we'll create a round tube that will later be cut to match the bottom bracket and head tube. You'll see it's very straightforward to do. For this, we'll use an operation we haven't used yet, the pipe operation. Since this is a new part, we'll create a new body by clicking the Create a New Body icon in the toolbar. In the tree view, press F2 to rename the body DownTube to keep the file organized. Since we'll use the master geo sketch as a reference for our sketch, it's essential to import it into the DownTube. To do this, select it in the tree view, then click the binder icon. Then in the tree view, you can hide the bottom bracket, the head tube, and the master sketch so that only the yellow binder for the DownTube is visible on screen. The goal is to create a sketch plane normal to the yellow line at this point. We'll draw our sketch on this plane, then use the pipe operation along this line, from the head tube down to the bottom bracket. To create this plane, select the yellow line and then the top endpoint while holding Ctrl. Then go to the Coordinate System tools and in the drop-down menu, choose Datum Plane. In the left menu, under Attachment Mode, select Normal to Edge. You should see the plane appear in the 3D view positioned exactly where we want it. Click OK to finish. Now we're going to create a sketch on the plane we just made, so select the plane in the viewport, then click on the Create Sketch icon. Using the Circle tool, draw a circle centered on the origin and set its diameter to 35 mm. Then you can close the sketch. In the viewport, we can see that our profile is positioned correctly. You can now hide the datum plane to make the 3D view clearer. The goal is to create a pipe operation using this profile along the yellow line. So, with Sketch 3 selected, click on the Additive Pipe icon from the top menu. In the left panel, under the Path to Sweep Along option, click on Object, then select the binder. Next, click on Add Edge and select the yellow line of the down tube in the viewport. You should now see a preview of the tube. If everything looks good, click OK to confirm the operation. Just like for the other tubes, we're going to hollow it out. Select the two end faces, then click on the Thickness tool. In the panel on the left, set the thickness to 2 mm. Now we need to trim the tube so it fits the bottom bracket and the head tube. Earlier I mentioned that we should have two separate operations, one for the solid tube and one for the thickness. That's because we're going to use the solid version of the tube to make the cut. It would have been much trickier if we had modeled it directly with its wall thickness. So we're going to use the revolution operation from the head tube and the pad operation from the bottom bracket to trim the down tube. To do that, we're going to call on our friend the binder. In the tree view on the left, select the pad operation from the bottom bracket, then click on the binder icon. Next, select the revolution operation from the head tube, then click on the binder icon. You should now see both of these operations appear in yellow inside the down tube body. You can also hide the bottom bracket to make things a bit clearer. To make the cut, we're going to use a Boolean operation. Let's start by removing the part of the bottom bracket. So, while holding Ctrl, select the down tube and then binder 2 and click on the Boolean operation icon. In the left menu, you should see only binder 2. In the drop-down menu, select Cut. You should see the part to be removed appear in red in the viewport, then click OK to confirm. Now we need to do exactly the same thing for the head tube. Hold Ctrl, select the down tube, then binder 3 and click on the Boolean operation icon. In the left menu, make sure binder 3 is selected. In the drop-down menu, choose Cut. In the viewport, you should see the part of the tube to be removed highlighted in red, then click OK to confirm the operation. So now the down tube should be properly cut, and the cuts will update when you change the dimensions in the master sketch. You can make the other tubes visible again to see the progress of your model. Before we go any further, let me introduce the sponsor of this video, PCBWay. They're a trusted name for both DIY and industrial projects. I had the chance to test their 3D printing and CNC services to create a bike chainring, and the quality was truly professional. You simply upload your 3D file, select your options, and you're set. Their standard 3D printing options are excellent. Plus, every new customer receives a $5 coupon for their first order. A big thank you to PCBWay for supporting this video. Now we're going to design the seat tube. Just like the down tube, we'll use a pipe operation and a Boolean to trim it. For this, we'll create a new body. Then in the tree view, press F2 and rename it Seat Tube. As with the other tubes, we need to import the master sketch into the new part so we can use it to create our sketch plane. To do this, select Master Geo and click on the binder. Then hide Master Geo so it doesn't interfere with our selection. Just like with the down tube, we'll create a plane normal to the yellow line of the seat tube at the top, exactly at this spot. To do this, hold Ctrl, select the small yellow line and the top point, then click on the Datum Plane tool. In the left menu, under Attachment Mode, choose Normal to Edge, then click OK to confirm. We'll create our profile on this plane. To do this, select the plane, then click on the Sketch tool. We'll use the Circle tool to draw our profile. Select the tool from the menu and place it on the origin axis. However, the view is blocked by the bottom bracket. To fix this, we can use the Section View tool, which will hide the bodies that are getting in the way. You can then draw the circle on the origin and set its diameter to 31.5 mm. Then click Close to exit the sketch. Next, we can create our additive pipe operation. First, hide plane 1 for a clearer view. Then, with Sketch 4 selected, click on the Pipe tool. In the left menu, under Path to sweep along, click Object, then select the binder in the viewport. Next, click Add Edge and select the small line of the seat tube. Repeat the same process for the line at the bottom, then click OK to confirm the creation. Now we'll hollow it out using the thickness operation. Hold Ctrl, select the end faces of the tube, then click on the thickness tool in the toolbar. Since we want an inner diameter of 27.2, set the thickness to 2.15 mm, then click OK or press Enter to confirm. Now, as you can see, we need to cut the tube according to the bottom bracket and the down tube. To do that, we'll use Boolean operations, just like we did for the down tube. To do that, we'll import the pad operation from the bottom bracket by selecting it, then clicking on our friend binder. We'll do the same for the additive pipe operation of the down tube. Select it and create a binder. You should now see the solid yellow shapes of the bottom bracket and the down tube in the viewport. Next, while holding Ctrl, select the seat tube and then Binder 5 and click on the Boolean operation tool. In the left menu, make sure Binder 5 is selected. In the drop-down menu, choose Cut. Check in the viewport that the red area matches the part you want to remove, then click OK. Now we need to repeat the exact same process for Binder 6. Hold Ctrl, select the seat tube, then Binder 6, and click on the Boolean operation tool. In the left menu, choose Cut. Check in the viewport that the red area to be removed is the correct part, then click OK. The cuts on the seat tube are now complete. We can make the other parts of the bike frame visible to see our progress. You can see that our frame is slowly starting to take shape. Now all that's left is to model the top tube to complete the front triangle of the frame. Unlike the other tubes, this one won't be used to cut any other parts, so we can even skip using a thickness operation. As with the other tubes, we'll start by creating a new body by clicking on the corresponding icon. Then press F2 and rename it Top Tube. Next, we'll import the master sketch into this part. To do that, select it and click on the binder. After all these binder creations, I hope by now you know the drill. Now we'll create a plane normal to the yellow line, but first we'll hide the head tube. Our plane needs to be placed exactly at this point. Then, while holding Ctrl, select the long yellow line and the endpoint just like this. Then use the Datum Plane tool from the toolbar. In the menu that appears on the left, under Attachment Mode, choose Normal to Edge and click OK to confirm. We're going to create our profile on this plane. To do that, select the plane in the viewport, then click on the sketch icon. Just like earlier, to get a better view, we'll turn on the section view to hide the other parts. Then, using the circle tool, draw a first circle centered on the origin point with a diameter of 28 mm. Still with the circle tool, draw a second one with a diameter of 24 mm. That way we'll have the tube thickness directly. You can then click Close to finish the sketch. Just like we did for the down tube, we're going to use an additive pipe operation to create the solid. To do that, with the sketch selected, click on the corresponding tool in the Operations toolbar. In the panel on the left, under Path to sweep along, click on Object, then select the binder. Next, click on Add Edge and select the long yellow line. In the viewport, you can check if the operation worked correctly, and if everything looks good, click OK to confirm. For this part, we just need to make the different cuts. To do that, select the head tube revolution and click on the binder to import it. You'll also need to import the additive pipe from the seat tube, so select it as well and click on the binder. You can also hide the seat tube if it's getting in the way. Then, while holding Ctrl, select the top tube and binder 8 and click on the Boolean operation tool. In the panel on the left, choose Cut. Check that the red area is indeed the part you want to remove, then click OK to confirm the operation. You will need to repeat the exact same process for the cut on the other side. Hold down Ctrl, select the top tube and then binder 9 and click on the Boolean operation tool. Set the parameter to cut, then click OK to confirm the operation if everything looks good. The front triangle of the frame is now complete. We can make the other tubes visible and hide the planes we no longer need. Now let's test if the frame adjusts dynamically without errors when we modify the master sketch. To do this, go all the way to the top of the tree view and double-click on the master geosketch to open it. Let's adjust the value from 533 to 560, for example, then exit the sketch to see if any errors appear. This might take a little time to recalculate, so don't panic. That's completely normal. In the tree view, we can see that there are no recomputation errors, so everything is perfect. We can go back into the master geo and set the value back to 533. Now we're going to work on the rear triangle, which is often the trickiest part when designing a frame. I usually start by creating and placing the dropouts, which hold the rear wheel in place. To position them correctly, you need to know the hub width of the wheel. For a BMX, it's usually 110 mm. So the first thing we'll do is create a plane to sketch the dropout. But before that, let's create a new body by clicking on the corresponding icon in the toolbar. Select the new body, press F2 and rename it to Dropouts. Next, we'll make the origin of the part visible. To do this, click on the eye icon next to Origin. In the viewport, select the green XZ plane and then click on the Datum Plane tool. We'll translate this plane by 55 mm, which corresponds to half the width of the wheel hub. To do this, go to the Attachment Offset option and enter 55 mm for the Z direction. Then click OK to confirm the creation. Next, hide Origin 10 in the tree view so that only plane 3 is visible. Just like for the other parts, we need to import the master geo to use it as a reference for the dropout placement. So select master geo, then click on the binder tool. You can hide the master sketch after that. We'll create a sketch on the plane we just made. To do this, click on the plane in the viewport, then use the sketch tool from the menu. The goal is to recreate this sketch. If it's easier for you, you can download it using the link in the description. The first step is to import the Chainstay line. To do this, use the external geometry tool and click on the yellow line. Exit the tool by right-clicking, then select the purple line and convert it into a construction line. To constrain our sketch, we're going to create two perpendicular axes. For this, use the line tool. Draw the first line starting from the end of the dashed purple line, making it horizontal. You can extend it all the way to the green axis. Next, draw a vertical line from the same starting point. If, like me, the bottom line isn't perfectly horizontal, select it and apply a horizontal constraint. Then select the two axes you just created and convert them into construction lines. To fully constrain the vertical axis, select it and apply a block constraint to make sure it doesn't move. We can now start the sketch. Begin by creating a circular arc centered on the green point. Use the arc tool, place the first point on the green point, then enter a radius of 7 mm. Press Tab to switch to the angle, enter 90, and press Tab again to enter the opposite angle and enter -180. Then press Enter to confirm. Next, using the Polyline tool, trace the shape of the dropout as I'm doing on screen. Start with a horizontal line, then a vertical line. Next, draw an oblique line that extends past the dotted line, followed by another oblique line. Then draw a vertical line that intersects the horizontal axis, another oblique line, a horizontal line, an oblique line, and finally a horizontal line that connects to the arc. Right-click to stop using the tool. If, like me, the last line isn't horizontal, select it and apply the horizontal constraint. Now we'll use the Dimension tool to fully constrain the sketch. Click on the Dimension tool in the top toolbar, then set a vertical dimension between the top point of the small left line and the horizontal axis, and give a value of 12 mm. Still using the Dimension tool, create a vertical dimension between the bottom point of the lower line and the horizontal axis, and set it to 14 mm. Next, create a horizontal dimension between the lowest point on the left and the origin, and set it to 22 mm. For the point just to the right, give it a horizontal dimension relative to the origin and set it to 3 mm. Then, still using the Dimension tool, give a horizontal dimension between the left point and the vertical axis and set it to 26 mm. Give a horizontal dimension between the vertical axis and the right point and set it to 19.5 mm. Then give a vertical dimension between the top right point and the horizontal axis of 11 mm. Still on the same side, add another vertical dimension between the axis and the point of 8.5 mm. For the topmost point, give it a vertical dimension relative to the horizontal axis of 29 mm. Next, create a right-hand angle between the slanted line and the horizontal axis of 44 degrees. Finally, select the 2 points on the left and apply a vertical constraint to fully constrain the sketch. Everything is fully green, so we can exit the sketch by clicking the Close button. To give volume to this dropout, we're going to perform a pad operation. With Sketch 6 selected, click on the pad operation icon. In the length settings, enter a value of 6 mm, then click OK to confirm the operation. For this type of frame, the dropouts are usually just a flat plate like we just made, but to get a cleaner result, we'll add a bit of material so the tubes can easily be joined. To do this, select the outer face of the dropout and create a sketch on it. Using the external geometry tool, we're going to project the 4 right edges of the dropout by selecting them. Once that's done, convert the 2 outermost edges into construction lines. Next, we'll offset the two other lines. Select them, then click on the Offset tool in the menu. In the Tasks menu on the left, check the box that says Add Offset Constraint and set the offset value to 3 mm. The sketch turns orange, which isn't a good sign. That means it's over-constrained. To fix it, go to the panel on the left, click on the number 30 and hit the Delete key. You can see the sketch is only partially constrained and some lines aren't actually needed. To fix that, start by converting all the outer lines into construction lines. Just select them and click the construction mode icon. Next, using the Line tool, close the contour by drawing a vertical line from the bottom point up to the edge, then add a second line from that new point to the right edge. You'll also need to close the contour at the top. Do the exact same thing there. Draw a small line to connect to the edge, then another longer one to connect to the top point. Then select the short line and the green line and apply a parallel constraint. You'll notice that the small line doesn't turn green. It still has some degrees of freedom. Try moving the top right point. That's the one that isn't fully constrained yet. Select that point, then the dashed edge, and apply a coincidence constraint. Our inner contour isn't completely green. We can see that at the bottom there's a point in the middle of the segment that's floating. It's not a big deal, we can leave it as is and then close the sketch. Even though the sketch isn't fully constrained, we shouldn't get any reconstruction errors. To create this small lip, we're going to use a pad operation. So with Sketch 7 selected, click on the Extrusion tool. In the length parameter, set it to 10.5 mm, then click OK or press Enter to confirm the operation. Now that we've finished the basic shape of our dropout, we can test if it moves dynamically according to the values in the master sketch. To do this, go to the master sketch, double-click to edit it, adjust the value from 330 to 340, then close the sketch. The recomputation might take some time, so just be a little patient. As we can see, there were no errors. The dropout moved correctly following the master sketch and rebuilt without any issues. We can consider that a win. Now we can go back to the master sketch, test a new value like 360, and check again to make sure there are still no errors after recomputation. No issues here either. Let's reset the value back to the original 330 so we can continue with our design. For now, our dropout looks a bit rough with those sharp corners. Let's make it more visually pleasing by adding some fillets. To do this, select these two edges while holding Ctrl, then click on the Fillet tool. Enter a radius of 7 mm, then press Enter or click OK to confirm. Next, add more fillets. While holding Ctrl, select the two front edges, then click on the Fillet tool. Then set a radius of 0.5 mm and press Enter to confirm. Next, select these three edges and create a fillet with a 4 mm radius. Finally, select the rear edge of the dropout and create a fillet with a 1 mm radius. We could still add more fillets to make the part even more appealing, but I'll stop here to avoid making the tutorial too complicated. We can test again if everything updates correctly when we change the chainstay length in the master geosketch. So, double-click on the master sketch, change the 330 value to 350 and then close the sketch. We can see that there are no rebuild errors, which is great news. In the tree view, you can hide binder 10 and plane 3 so they don't get in the way for the next steps. Now we need to design the chainstays and seatstays. We'll start with the chainstay, and to do that we'll go back into the master sketch to add some new construction lines that will help us design them. We're going to use the Line tool to draw a line that will help us position the plane where we'll sketch the path of our chainstay. To do that, click on the Line tool, then draw a line starting from the Seatstay area above the origin and ending near the point of the dropout. While we still have the Line tool active, let's also draw the one for the Seatstay. Start the line just above the junction with the top tube and end it above the dropout. To fully constrain the sketch, we're going to align the 3 points. To do that, select the points one by one, then apply the horizontal constraint. To finish constraining the sketch, we'll use the Dimension tool. Set the height of the chainstay point to 2 mm above the origin and do the same for the seatstay point, 2 mm as well from the junction. Also set a distance of 14.5 mm between the 2 points at the end of the sketch. Finally, we're going to constrain the bottom black line by setting an angle of 75.7 degrees between the seat tube line and the black line. After that, our sketch should turn fully green, meaning it's fully constrained. So you can exit it now by clicking the Close button. The goal now is to create a plane on this new line. To do this, we'll start by creating a new body by clicking the icon on the top bar tool. In the tree view on the left, select the body, then press F2 to rename it to Chainstay. As with the other parts, we need to import the master geo. To do this, select the master geo and then click on the binder tool. Also, you can hide the master sketch. To create this plane, we're going to make a plane normal to our line and then rotate it by 90 degrees. To do this, hold Ctrl, select the bottom line and its endpoint. Once both entities are selected, click on the Datum Plane tool. In the left menu, select Normal to Edge. However, we want the plane to be perpendicular to it, so in the attachment parameters, set around x-axis to 90 degrees and you'll get your plane correctly oriented. So now we can trace the path for the chainstay. The goal is to recreate this sketch. Don't forget, you can download it from the link in the description. To do this, select the plane, then click on the Create Sketch tool from the menu. To constrain our sketch, we need to start by importing certain entities. For this, using the External Geometry tool, we'll import the origin point where the bottom bracket is placed. Next, we can realign the view by clicking on the Normal View to Sketch tool in the toolbar menu. To access our projected point, we need to activate the Section View tool. Click on it, and you should see the point appear. Here we need to account for the wheel clearance and represent it as a construction line. For this, we'll use the Line tool to indicate the wheel radius. Start the line at the origin point and give it a length of 265 mm. Next, select the line and convert it into a construction line using the Construction tool. Then, using the Circle tool, draw a circle at the end of the line and give it a diameter of 50 mm. Then select the circle and convert it into a construction line. Now we're going to draw our profile, shaping it so that it avoids the wheel tire. As construction lines, we could have also added the position of the chainring and the crank arm, but I didn't want to make the tutorial too complicated. We'll start the sketch by using the Line tool to draw a small horizontal line starting from the projected point. Next, we'll use the B-spline tool to draw the rounded shape. Start by placing the first point at the end of the small line, then a second point below the first, a third point to the left, a fourth a bit further left, and a final one on the red horizontal axis. To stop placing points, right-click. You'll see the curvature comb lines of the spline appear. If they get in the way, you can hide them by going to Sketch, then Visual Helpers, then Toggle B-spline Information, then Toggle B-spline Curvature Comb. That should make them disappear. Now we are going to constrain our sketch, starting by selecting the two top points of the spline and applying a verticality constraint. To do this, select them and click on the verticality constraint icon. Next, using the Dimension tool, we'll give a horizontal dimension of 16 mm to the small line. For the first curvature point, we'll give a vertical dimension of 30 mm relative to the projected point. Then, still using the Dimension tool, we give the second curvature point a vertical dimension of 58 mm. To fully constrain it, we can also give it a horizontal dimension of 45 mm. For the third curvature point, we'll give it a vertical dimension of 88 mm. Then, still using the Dimension tool, we'll give it a horizontal value of 43.5 mm. To fully constrain the sketch, we just need to give a horizontal dimension to the point near the dropout. Using the Dimension tool, set that distance to 64 mm from the point to the vertical axis. The sketch is now fully defined and complete. As I mentioned earlier, for a more precise design, you could add construction lines for the chainring and crank arm to make sure everything fits properly. But for now, we'll keep it simple. You can go ahead and end the sketch by clicking Close. Now that we've got our path ready, we still need to create the different sections for the tube. This tube will have one unique profile near the bottom bracket and another one near the dropout. But before that, let me hide the bottom bracket because I think I forgot to convert one of the lines into a construction line. Yeah, that little segment shouldn't actually be visible. Let me just go back into the sketch and turn that line into a construction line. There we go, problem solved. Now we're going to create a plane that's normal to the curve on the bottom bracket side. To do that, select the curve, then the endpoint, and click on the Datum Plane icon. You can keep these settings and then click OK to confirm. To create the profile, select the new plane, then click on the Create Sketch tool. On this side, the profile will be quite simple, just a circle. Use the Circle tool to place it at the origin, give it a diameter of 19 mm, and then you can exit the sketch. We also need to create a profile on the other side. To do this, repeat the same process. Create a new plane by selecting the curve and its endpoint, then click on the Datum Plane tool. As before, keep these settings. Then in the viewport, select the plane and click on the Create a Sketch tool. Our origin is hidden by the dropout. Click on the Section View tool to make it visible. Then for this profile, we're going to draw an ellipse. Open the Circle menu to find it. Then create it at the origin of the axis and give it a first value of 6.5 mm with an angle of 180 degrees and a second value of 8.5 mm. Normally after this, the shape should be green and fully constrained. You can then close the sketch. Now we need to create the solid. To do this, we'll once again use a pipe operation. First, in the tree view, hide the binder and the three planes. Then select Sketch 9 and click on the additive pipe icon. In the right-hand menu, click on Object, then select the curve in the viewport. Next, click on Add Edge and select the same curve. You should see a green preview of our tube, but as you can see, the second section hasn't been taken into account. To fix this, go to the right-hand menu and set the Section Transformation parameter to Multi-Section. Then click on the Add Section button and select the second profile in the viewport. You should see the preview update showing that everything is working as expected. You can confirm the operation by clicking on OK. You can see that the tube has been created correctly, but it looks a bit low poly. This depends on your default settings, and FreeCAD gives a fairly low value by default to optimize performance. If you want a smoother preview, select the Chainstay in the tree view, then in the view properties, adjust the angular deflection to a smaller value like 6. To apply the change, you need to recompute and refresh your model. I won't do it here, but trust me, it works. Since our tube needs to have a thickness, select both end faces while holding Ctrl, then click on the Thickness tool. In the left-hand menu, set the thickness value to 2 mm, then confirm by pressing Enter. Now we need to cut our tube so that it fits with the other parts. On the bottom bracket side, this is pretty straightforward. As we did for the other tubes, we need to import the bottom bracket pad operation. To do this, select it in the tree view and then click on the binder. We also need to import the dropout. To do this, we'll import pad 02 in the same way. Select it and then click on the binder. Now that we have our two bodies, we can perform the cut. To do this, locate the chainstay in the tree view, then while holding Ctrl, select the chainstay and binder 12 and click on the Boolean operation tool. In the right-hand menu, set the parameter to cut. Then check in the viewport that the red area corresponds to the part you want to remove and click OK to confirm. Now we will do the same process for the dropout side. In the tree view, hold Ctrl and select the chainstay. Then select binder 13 and click on the Boolean operation tool. In the menu on the left, set the operation to cut. Check in the viewport that the red area corresponds to the part to remove. Then click OK. It's possible that FreeCAD might refuse the operation because it would create two solids in one body. If that happens, go to the chainstay properties, check Allow Compound and then redo the Boolean operation. We are going to do some heavier operations for FreeCAD, so it's definitely time to save. I'm going to give my file a very original name like Bike Frame Tutorial and then click Save. We can see there's still a small piece of tube floating in the air. The cut on the bottom bracket side is perfect, but there's still that left over on the dropout side. To remove it, we'll need to switch workbenches. Go to the Workbench drop-down menu and select Part. With the chainstay properly selected, go to the Compound drop-down menu and choose Explode Compound. In the tree view, you should see a new folder containing the two separated parts of the tube. Simply select the part you want to remove, in this case the small leftover piece, then press Delete. This should remove it. Now we're going to move on to the Seatstay, that's the tube just above. This time we'll use exactly the same process as before. So let's switch back to the Part Design workbench using the drop-down menu. In the left menu, click New Body, then go to the Model tab. We'll rename it using the F2 key and call it Seatstay. Just like we did for the chainstay, select the master geo and import it by clicking on the binder tool. Once again, we'll need to create a plane to draw the tube path. To do that, hold Ctrl, select the upper yellow line, then its endpoint and click on the datum plane tool. In the left menu, select normal to edge, then in the attachment offset settings, set a rotation around the x-axis to 90 degrees. Press Enter to confirm. We can see that our plane was created exactly where we wanted and with the right orientation. To start our sketch, select the plane and click on the Create Sketch tool. Some parts might get in the way while sketching, like the bottom bracket. To see through them, click on the Section View tool. That'll temporarily hide those parts. Then we need to project the yellow line into our sketch to get the intersection point. If it's hard to see, you can disable the section view and rotate the camera a bit until you can select it with the External Geometry tool. Now that our line is properly projected, we can select it and turn it into a construction line using the corresponding tool. We can now realign the view so that it's normal to the sketch using the Sketch View tool, then turn the section view back on. The tracing here will be simpler. We'll use the polyline tool and draw 3 segments starting from the projected point. First a short horizontal line, then a second line going downward, and a third angled line that ends on the red axis. Right-click or press Escape to stop using the tool. Next, we'll use the Dimension tool to constrain our sketch. Find the tool in the top bar, then give the small top line a horizontal dimension of 6 mm. After that, convert this small line into a construction line using the corresponding tool. Next, using the Dimension tool, set an angle of 20 degrees between the first oblique line and the vertical axis. Then, still with the Dimension tool, give a horizontal distance of 45 mm between the point and the vertical axis. Finally, to fully constrain the sketch, select the bottom point and give it a horizontal distance of 64 mm from the vertical axis. No real-life tube has such a sharp bend. We're going to round it off using the Fillet tool. To do this, select the Fillet tool and then click on the 2 segments on either side of the point. Then, using the Dimension tool, give it a radius of 100 mm to create a nice rounded bend. The sketch is now complete and fully constrained, so you can exit it. Now that we have our path, we can create a plane for its profile. But before that, let's hide plane 7 and binder 14, since we won't need them. You can hide also the dropout. Then, to create the new plane, hold Ctrl, select the path and its bottom endpoint, then click on the Datum Plane tool. In the left-hand menu, select Normal to Edge and then click OK to confirm. The tube's profile will just be a small ellipse. To create it, select the plane we just made, then click on the Sketch tool. As usual, if any element gets in your way while drawing, use the Section View tool to hide it. Then, using the Ellipse tool, place the first point on the origin of the axis, give a first value of 7 mm with an angle of 180 degrees and a second value of 9 mm to finish the sketch. You can then close it after that. Now we're going to do the additive pipe operation to create the tube. Before that, hide plane 8, then select Sketch 12 and click on the additive pipe icon. In the left menu, click on Object and then select the path. You should see a green preview of the tube. Click OK to confirm the creation. Now we're going to hollow it out. To make selection easier, hide the seat tube. Then in the viewport, hold Ctrl, select the 2 end faces and click on the Thickness tool. In the left menu, set the thickness to 2 mm, then press Enter to confirm. As with the chainstay, we need to cut our tube so it fits perfectly with the others. To do this, we need to import the seat tube and the dropout. In the tree view, select the seat tube additive pipe and click the binder. Then, still in the tree view, select pad 2 of the dropout and click the binder. Next, scroll down in the tree view, then while holding Ctrl, select the Seatstay and binder 15 and click on the Boolean operation tool. In the left menu, set the parameter to cut. Check that the red part corresponds to the portion you want to remove, then click OK to confirm. To remove the rear part, while holding Ctrl, select the Seatstay and then binder 16 and click on the Boolean operation tool. Change the parameter to cut, then click OK to confirm. In the tree view, we can make the seat tube visible again to get a better overview of our bike frame. To get rid of that small piece left behind, we need to do the same thing we did for the chainstay. We need to switch to the part workbench, then use the Explode Compound tool. In the new exploded Seatstay folder created in the tree view, we can delete the small solid we don't need by pressing Delete. I don't know if you noticed, but we're missing the entire left side of the frame. Since we're not cavemen, we're not going to remake everything tube by tube. We're going to use a mirror operation. To do this, in the tree view, while holding Ctrl, we're going to select the dropout, the chainstay, and the seatstay. Then we're going to use the mirror tool. In the Shapes menu, we're going to check that our parts are correctly selected. Then in Mirror Plane, we're going to choose the XZ plane and then click OK to confirm. The major part of our bike frame is now complete. I want to congratulate you on making it this far. You have just accomplished something big. If, like me, these low poly tubes bother you, you can change the deviation angle for each of them, then right-click on the body and recompute it, and you'll get a nice smooth result. Now that we're happy that our bike frame is finished, we need to test if it reacts well to dimension changes in the master sketch and see if it rebuilds without errors, and check if we've done a good job. To do this, double-click on the master geo, then change the value from 533 to 540 and from 350 to 330. Avoid values that are too extreme, then close the sketch. And after 10 business days of calculations, your model should have recalculated and you shouldn't have any errors. To wrap things up, we'll add a couple of final elements. These are just small reinforcements that go between the rear tubes to maximize the frame's overall rigidity and strength. To do this, we're going to switch back to the Part Design workbench. In the left menu, we'll click on New Body and then we'll go into the Model menu. We are going to import the master GO into this body by selecting it and clicking on the Binder tool. Then we'll create a new sketch, choosing the XZ plane as the attachment plane. To hide the tubes, we're going to use the Section View tool again. We'll start by creating the bottom reinforcement. For this, we'll use the External Geometry tool to project the top line of the chainstay. Next, we select this line to convert it into a construction line. Our reinforcement will be a round tube, so we'll use the Circle tool and place the center on the purple line, giving it a diameter of 16.5 mm. Still using the Circle tool, we'll draw an inner circle of 12.5 mm. Next, we'll go for the Dimension tool and give it a parallel value of 40 mm. We can then exit the sketch by using the icon or by clicking Close in the Tasks menu. Next, we're going to perform a pad operation. Choose Pad in the Task menu. In the Tree view, use the red arrow to extrude towards the chainstay, making sure they intersect. I know this isn't very elegant, but the face of the chainstay is cut in half, so I can't use the option to extrude up to the face or up to the shape either. So we'll do it this way, it works well. To still get a clean result, we're going to cut the body along the chainstay. We'll import the additive pipe of the chainstay into the body by selecting it and using the binder. Next, while holding Control, we're going to select the body and then Binder 18, and we'll use a Boolean operation. In the left menu, change the setting to Cut. We can clearly see the inner part in red that will be removed, then click OK to confirm. To finish this tube, we're going to perform a mirror operation. To do this, select the Boolean operation and then click on the Mirror tool. In the left menu, select Transform Body, then under Plane, select the XZ plane and click OK to confirm. Next, go to the Tree view and use the F2 key to rename the body to T1, for example. Now all we have left is to do the same thing for the top reinforcement. I'm going to speed up the video because it's exactly the same process. Try to do it on your own, like it's a piece of homework. If you get lost, you can just slow down the video on the player. We've now reached the end of the tutorial for this bike frame. I think this is the most complete tutorial I've made so far, covering a huge number of simple and semi-complex operations. I truly hope this has helped you better master this fantastic software that is FreeCAD. Don't hesitate to let me know in the comments what kind of topic you'd like me to cover in a future video. If you liked the content, please feel free to let me know and subscribe to the channel. Thank you for your attention.